This is lesson 7, and the topics for this lesson today are going to be Digital Elevation Model, NDE, Triangular Interpolation, TIN, Flood Analysis, Topographic Profile, 3D Model, Plugins to install Interpolation Plugin, QGIS2threejs, and Profile Tool. And the tools we are going to use on this Quantum GIS are Reproject a vector shapefile, create layer, new shapefile layer, vector, geoprocessing tools, clip toolbox, processing toolbox, grass, GIS7, vector B, Clean-toolset for cleaning topology of vector map. Websites we are going to visit today are geogratis.
Hello everybody, today we are going to do a digital elevation model. For do that one, first we have to download a vectorial file, shapefile. We can use the link that we was using at the lesson 2, I believe it was, or lesson 1, copy. Then here we have to go this option, download maps and data, use a vector data. Then here you can see we have to select 50 because it's going to be 50K. Then here is going to be elevations in Canada. Shapefile, this one, and then here we are going to select the Alberta province. I have already the folder for this lesson. I'm going to pass the video faster for this part. Okay, that's complete. Let's go to extract here. We have all these files. Now we are going to open Quantum GIS. We have here all the metadata for this file. First, we are going to define the project properties. We are going to be working on the coordinate reference systems WGS84 UTM Zone 12 North. Okay, we are going to do a digital elevation model for this area. We was working the other day in this area, and we are going to continue. Okay. First, what I want to do is add the file we downloaded. It was lesson 7. We have for all Canada, for all the province of Alberta. Okay, that's a heavy file. Zoom to the layer. This is our area. Then what I'm going to do is to click all this area because we are going to use just with this information here. But first, what I'm going to do is change the coordinate systems for this file, because if we check here, this coordinate system is not 83, okay, and we want WGS 84 UTM zone 12. Then I'm going to change, going to save as zone 7, going to keep here as control 50K WGS 84 zone 12 north. When you are saving files to work in a GIS software, it's better not to leave any space in order to avoid errors, okay? Then the coordinate systems, as we said, is going to be this one, okay, and okay. Okay, it took around 1 minute to change the coordinate reference systems. Then let's go to remove this one. Now we have projected already the contour. Now we are going to create a polygon to clip all this area. To do that one, layer, create layer, new shapefile layer. It's going to be a polygon. The coordinate systems is this one. Name is going to be square. The other ones is okay. Let's go to save here. In lesson 7, save. Select here, click on the pencil, click here to add feature. From here to here to here and here. Click right, ID number 1. Okay, we have that one already there. Now we are going to finish the edition, save, and now we are going to put this one transparent, and make this line bigger, 5. Apply, okay. We're going to cut that area there. For do that one, just go vector, geoprocessing tools, and clip. First input layer is the layer we are going to cut, is that one, the contour. Then clip layer is the shape you want for that cut, is going to be the square. And here you can, if you leave that like that one, you are going to create a temporary layer, but you can save directly. Save. Lesson 7. And we are going to put here the contour cat. WGS 84 UTM zone 12. Save, and let's go to meet the process. Okay, that's already complete. As you can see, we don't need this one. Remove. Okay. And now, in order to make the digital model, the digital elevation model, we have to go raster, but first we have to add the plugin. The name of the plugin is Interpolation is this one, Interpolation Plugin. You have to click on the box, close, then go raster, and you have interpolation already here. Interpolation. Okay, click here. The vector layer with the contour lines is this one, clipped, and here you have to select the interpolation attribute. As you can see here, if we open the attribute table, you have a lot of different columns, but this one is the elevation. Okay, I'm going to show you. Let's go to put properties, levels, show E, apply. Okay, as you can see there, that's the altitude. Okay, but in this case, when we try to do when we try to create the triangular interpolation, DIN, we don't have the elevation, the column in these options, because it was just E. Then first, before to do the interpolation, we have to clean this layer. Okay, this vectoral layer, we have to eliminate the topology errors in this layer. Okay, to do that one, we have to go to processing. First of all, no, let me check. Toolbox here. Go to the grass here, vectorial, and we have to look for clean topology. Is this one here, toolset for cleaning topology of vector map. Double click, then here put the layer. It's going to be this one. This option is okay. We are going to, after the process, let's go to create a temporary file. Then let's go to save. Okay, run. Okay, we have here cleaning. This one, we are going to remove this one. Cleaned, as you see here. Save as. Cleaned. Save. Okay. Let's go to remove this one. Okay, and this one. Okay, let's go to close this one. And now it's the same as before, but it's suppose we clean all the errors, and now it's ready to do the digital elevation model. Yes, raster, interpolation. Now you can see we have the elevation to select. Then add here, select point. For the interpolation method, we are going to select TIN. Here we are going to leave this one as a linear. For the size, we are going to put one, and one here. Okay, now we are going to select where we want to save the file. It's going to be here, save, and okay. That's our model. As you can see here in black is the for the altitude, okay, the maximum and the minimum. Let's go to change the colors for the model. In a style, here you have to go pseudo color. Then you can select the ramp you want for these colors. There are different options. Even you can edit whatever you want. For example, apply. Okay, we have to classify first. Classify here, then apply. That's the model. Now if you want to change the colors, even you can invert. Apply. Okay, now I'm going to change this color because I don't like it. I'm going to use a green one, something like that. Apply. Okay, that's okay. Now we are going to do the 3D model for this one. To do that one, we have to download one more plugin. The name of this plugin is QGIS2. Is this one here? QGIS2threejs. That's a very good plugin. As you can see, it has 5 stars, and there are a lot of downloads. Install. Click on the box, okay, close, and we have the model here. Before to use this plugin, I would like to tell you something about this kind of shape. As you see, the information we have for the contour, you know, it's over here, but we don't have any information here, we don't have any information here, we don't have any information here, and that's because the reason the shape of the model is this one, okay? And also other important thing, this model, this Topology elevation model is very simple, you know, because there are just a few lines, and that's is scale 50K, okay? It represents 1 millimeter on the map. It's 50 meters on reality, right? Then you have information just every 50 meters, more or less, right? If you have another kind of contour map, you know, for example 20K, the precision of the topography is going to be better because you are going to have more contour lines, and the surface is going to be more realistic, right? Even if you have a LiDAR file, you know, the resolution is going to be, for example, a couple of points of information about the altitude every 1 meter square, right? And the resolution for that kind of files is really good, and the model you are going to get is going to be very close to the reality. Okay, in this case we are working with a 50K. That's a very big resolution for a small area like this one, but that's the information we get for free. Okay, if you want more resolution, better resolution for the digital elevation model, you have to pay for more accurate information. Okay, after that we are going to run the model. I'm going to take this one, and I'm going to take this one, sorry, this one. But before to do the model, we have to do a mask here to get a better model. Then go layer, create a new shapefile layer. It's going to be a polygon. The coordinate systems is that one, QGIS84 UTM zone 12 north. It doesn't matter the name, I'm not going to put any name. Here, mask, save, and let's go to create the polygon we want. You want a polygon inside the team. Okay, one, finish. As you can see, I am leaving some space here, some room here, you see. Okay, now we are ready to do the model. Go here. Here there are different options. Okay, you can play with these options. We are going to leave like this one. For the world here, that's okay. Controls, you can see the controls here, and you have a couple of different options. I'm going to leave this one here, the model. That one has to be the team. Okay, first close. I'm going to finish the addition, save. Okay, we was here. Then layer has to be the team, this one. This one is for the resolution. Okay, we are going to put the maximum. Here there are some different options. Here, for example, you can select the image you want on your 3D model. I'm going to select this one. Also here we have for the resolution of the satellite picture for this one. And here we can choose clip, and we are going to use mask. It's the mask we created. Okay, and we are not going to mark any of these ones. Okay, that one it's ready to use. Okay, run. Okay, we have the model here. As you can see, that's in 3D. Okay, the resolution is really good. Okay, and there are a very interesting tool I'm going to show you. Is this tool here. Then I'm going to change the color. I'm going to choose a blue one, something like this one. And now if you go here, you can put the altitude here, for example 360. You see this mask here at the bottom, 340. You can move that one. You go to the top. That's a very interesting tool. 630. Okay, 630. Maybe 629. 629. If you go 1 meter up, 630, you can see 631. We can go up 1 meter. This is the altitude, okay, guys? That's a very interesting one. You see, you can apply some transparency here. Okay, 632. $33. 34. 640. You know, that's very interesting. And if you are doing something related with float, that's a very interesting tool to use. You can move also here. Okay, that's for the 3 model. These 3D models are very interesting because we can do a lot of things, okay? We was using this one in order to make a representation of the surface, right? But we can use this kind of models to represent a lot of different things. For example, we can make a representation of the groundwater table. If we have a lot of wells and we can take the water table, we can make a 3D model of the water table in order to see what is the flow direction, for example, right? Even, for example, if we have a contamination related with hydrocarbons, for example, a gasoline contamination, right? And you have a layer, a thin layer that it's very permeable, where the hydraulic conductivity is really high because it's a layer of sand, and you have a lot of boreholes with this layer. You can make a 3D model of this layer in order to know what is going to be the migration of the hydrocarbon, right? How is going to move that hydrocarbon in that layer, right? There are a lot of interesting things you can do with these 3D models, okay? Just the limitation is our imagination, okay? Even in this case, you can represent, for example, 3 different kind of things in the same project, okay? Could be the surface, could be a layer of sand, and even the groundwater table, and you can make all these 3 layers in the same project in order to see what is the conceptual model, right? Okay, even for example, I'm thinking now that, you know, this is our area, and we have a couple of water walls, groundwater walls, okay? And for this one, we have some information here. There are a lot of information for this groundwater wall, okay? They use either what is the water table, okay? In this case, the water table is more or less the same as the level of the water on the river, okay? And that indicates that there are a relation between the groundwater table and the river, okay? That's pretty normal because it's very close to the river, right? But you know, you can know all this information without going to the field, just working with free data, okay? That is really good. Even there is a pumping rate with a lot of information, the geology, and that's for the pumping test, maybe. You know, there are a lot of information in this report you can use without going to the field. That's very nice. Okay, and also I would like to talk about other kind of tool we can use when we have a team like this one. Okay, we have to install a plugin first. The name of this plugin is Profile. Okay, is you put here, you can write here Profile, and it's this tool. So click install the plugin. Click on the box, just already click, close, and is this one. Then click, and then you have to select the layer you want to use. In this case, it's going to be the tin at the layer. Okay, then yes, you have to make a line to get the profile. Click and double click to finish the line, and you have the profile there. Okay, as you can see, this small square is this line. When you are moving, you can see on the top the small square is moving, and here you have the altitude, and here you have the distance of the line. Everything is in meters, and that's really good because, you know, if you are here, you can see the altitude here, the altitude. Okay, here, let's go to change the profile, something like this, you know, something like this. You can use this information for a lot of different things. Even here at table, you can copy to a clipboard and open in Excel, and you know, you can do whatever you want with the data. Even here you can have different formats to save, and you can open with other softwares. Here is the maximum altitude, and here is the minimum altitude for this profile. In this case, this one is going to indicate the level of the water. Okay, that's it for this lesson, and see you on the next lesson.